Hi friends, thank you for joining me. So I'm going to be actually attending a class for teachers where we talk together about strategies and ways that we can learn about and teach science. And so what I thought I would like to do is to give you a little bit of an entertaining tutorial where I can show you one of the experiments that I recently tried. So I noticed I sometimes walk on the Piermont Pier. Maybe some of you have been there as well. And at the very end, there is it looks like a little building, a little tiny rectangular building. And inside there are these huge microscopes and test tubes and things like that. And one of the things that the scientists do there is they test the water quality that surrounds very close to us in the Hudson River. And they also take a peek at what's underneath the Hudson. They take a look and see with the rock formations that are under there, they test and see what's going on with it. So I figured it was the perfect place to try an experiment involving water. So you'll see that in a little bit. But the first thing I wanted to do was talk to you a little bit about some special science words, as I mentioned. So one of the first words that we're going to talk about is a word called variable. So a variable, as you can see, I used a bullet point because I did not write a full sentence here, but I wrote something that we change in an experiment. So a variable is one part of an experiment that we want to kind of focus on and see if we change it, what does that tell us? What data does it give us? What does it tell us about what happens? And then the next thing we're going to talk about is if something is a fair test. So if we're testing materials and we're seeing what happens with them, our goal is to change one variable. We want to see what's actually happening, what's causing the change. And if we change too many things, as you're going to see in my experiment, we won't be able to focus on exactly what we're wanting to measure. The last thing is the actual topic of my experiment. I'm checking the absorbency of different types of paper. So I'm going to kind of give you a moment here to make a hypothesis. I'm going to share with you exactly what I tested. So let's talk about the word hypothesis. Hypothesis is a big fancy science word that basically just means making a smart or an educated guess about what's going to happen based on what you know. So because my experiment is going to be about testing 3 different kinds of paper and how much water they can absorb, let's kind of think about what those pieces of paper usually do. So take a minute to yourself, think, what do we usually use copy paper for, right? Where you get your workbooks and things like that from. What do you usually use construction paper for, right? Do you paint on it? What happens when you do paint on it, right? The last thing is think about paper towel. Think about how we use it around the house or at school. Think about what its job is. So you can already start to, like I said, get that educated guess in your mind and think about what is going to happen when I do my experiment. Which one is going to soak up the most water? So take a minute to think about that before we move to the next step. Went down to the river, like I mentioned. I went to the Piermont Pier and I went with some pieces of paper. I measured and I took a piece of paper towel. I took a piece of copy paper. My paper towel kind of melted in the water a little bit, so it didn't quite make it back home. I also tested some copy paper and some construction paper. And as you can see, they're still a little bit wrinkly and wet. So kind of some of the properties that we talked about already. So you're going to see in the experiment that I was testing the absorbency, or the amount of water that they were able to hold in. And what I'll do is I'll explain and you'll see in the experiment what I discovered. Hi friends, we're down here at the Lamont Doherty Earth Observatory. There's a field station here where water is checked and scientists are down here experimenting. There are some large microscopes in there and some testing equipment. So this is where the real scientists work. They take a look at the water quality. They take a look at what's underneath the water. You can see here that it was created in 1949, and they use the dock at the end of the pier here and use it to use boats to look underneath the water and see what's going on with the Earth's movement. So we are right in the spot where scientists like to study the water and see what's going on in it. And we're going to use this spot to do our own experimentation. And one of the things that we're going to talk about today are the variables in an experiment. So you're going to see our little experiment set up right here. Okay, and the things we're using are a bit of paper towel. We are using some construction paper and we are using some copy paper. And as you can see, I put a little bit of green coloring into my water to see if that affects anything. Some of you may have tried this already with regular tap water. We are here, like I mentioned, at the Hudson, and we are using what's called brackish water because the Hudson water, it has a little bit of a salt content in it because of what is here. So we're going to see if that affects our experiment results at all, and I will let you know when we get to the part where we put down our data. So the first step, the first thing we're going to do is we are going to dip in. You can see here, each piece of paper has a spot where it's bent in half. So we're going to take one end of the paper and we're going to dip it into the water. Perfect. And we want to dip it in we put the same amount of water in each of the cups, and we want to dip it in the same amount of space and see how much gets absorbed. Yep, and then we'll take the next one. That's the copy paper.
This is the construction.
Okay, we'll dip it into here. Again, we use the same amount of water. We kept that variable the same. So we're going to dip that in, see how much gets absorbed there. Yep, and then let's see the paper towel. Let's see what happens. All right, let's dip it in. Dip, dip, dip. See what happens.
I have a feeling the paper towel will be the most.
So I have the same hypothesis. I think the same thing because obviously for what we use it for too, right? We have to think about too our hypothesis based on what we use all of these items for, right? We want to use paper towel for cleanup, and we typically use copy paper and construction paper for our work, right? So we're going to take a look. I'm going to mark on the line. I'm going to mark here where it absorbed up to see our absorbency, and then we'll go ahead and we'll measure. Okay, so here, let's make a little line mark here about where our water went up to here as well. Okay, we'll make a mark here, and then last but not least, our poor little paper towel here got a little squished, but we'll stretch it out. And can you just make a quick line there for me, please?
Right here?
Yep.
Okay, where? Like right
Up to the watermark, yep. So actually we could probably do it next to it and then I'll still be able to measure. Yep, that's good. If you want to just make a line, there you go. Great, and then we'll measure the line, perfect, because our paper towel did get a little squished. Okay, so what we did, just to refresh, we have 3 cups, small cups, all filled with the same amount of water. We all colored it green so we can kind of see a little bit more on our paper where it absorbed up to. Yeah, we can put our pen there. We took 3 different kinds of paper, and the variables that we kept the same are the same type of water. We kept the same amount of water, and we're doing it all at the same time, and we dipped it in the same amount as well. Okay, so our next step is going to be that we're going to use our ruler. We are going to measure in centimeters to see how far it absorbed up to, where was our water line, where was our absorbency line. The next thing also too that I want to mention is if you don't have a ruler, if you end up trying this, you can always use, like we practiced, the tip of our pinky is about 1 centimeter long, so you can always kind of mark and move. You can kind of put your finger there, mark it, and then move and kind of estimate also. So that's another strategy that you can use. All right, so for right now, we're going to use our centimeter ruler, and I'm going to measure here the first line. Okay, so that is about, let me make sure I'm at 0 where our paper towel got a little squished, and I'd call this 8 centimeters. So I'm going to actually write this down on my plate. We had a lot of things to carry, so I did not carry my data journal with me. So what I'm going to do is I'm going to keep it on the plate, and then I will add it into my science notebook a little bit later, and we'll talk about that. So now I have paper towel absorbed up to 8 centimeters. Then I'm going to do the same thing over here. I'm going to take my centimeter ruler. I'm going to measure, and as you can see, it's about, I'd call it 3. So we're going to call that 3 centimeters.
And also the color of the water.
Yep, do you mind writing that down for me, please? I'm going to hold
3
this.
centimeters.
Yep, 3 centimeters. Perfect. Just be careful, the plate might move a little bit. There we go.
Oh, CM.
Yep, CM, exactly, our label right there. And last but not least, our copy paper, so let's measure that.
Like 2 inches maybe?
2 centimeters,
yeah,
right?
2
Yep, we're going to estimate a little. Let's see if you're right. I would agree you're probably about right. Let's see.
Yeah.
Yep, I'd call that about 2 centimeters. Maybe a smidge less, but we'll call it 2 centimeters. Good, so I'll put 2 centimeters on our plate over here. Perfect, and that's our copy paper. All right, so as you can see, we're not quite done with our experiment. We still obviously have to write it down into our notebooks into our science journal, but we're going to go ahead and we're going to keep it as it is so that we can take all this information with us and we can process it and write down what we found into our science notebook, into our science journal. So now that I'm home, I'm going to take what I collected and I'm going to take what is called, it's my raw data, right? It's information that I just wrote down on what I had and I just kind of got it down so I don't forget it. And now I'm going to put it in a little bit of a better place, my little science notebook here. Now, one thing that's important to think about when you're thinking like a scientist is that you can kind of take, like I did, whatever you have around, jot down your notes, and as long as it's labeled, which is why we practice that in math too, and as long as it's labeled, you can always take that information and put it back in a different spot later on, which is exactly what I'm going to do now. So as you can see, I gave my testing a title, right? My FAIR test has a title. So I wrote testing absorbency. And what I wanted to do, again, was focus on how much each type of paper could absorb in terms of water. How much water could it take in? And I did that by measuring. I also put a date because when you're studying science, you want to make sure you date all your information in case you have to look back at it for any reason. So I listed here, I put paper towel, I put construction paper, and I put copy paper. So what I'm going to do is I'm going to take the plates where I wrote down my notes and my measurements. Okay, my daughter helped me out with that. And I'm going to write that down into my notebook. So the first thing I'm going to find is construction paper was 3 centimeters. So I'm going to write that down here. Then I'm going to find my paper towel. Here was 8 centimeters. Okay. And last but not least, my copy paper is 2 centimeters. So I'm going to write that down here. Okay. As you can see, I labeled everything and I labeled centimeters and I put it down here. Okay. Because centimeters was the measurement that we just practiced recently. Okay. So we're going to take a look and I'm going to actually make myself a little bit of a graph because I want to kind of think about how I want to show the difference. So what I'm going to do is I'm going to make what looks like an L. Okay. Just like that. And I'm going to label at the bottom. I'm going to put copy paper. And this is not too fancy. I'm not even using a ruler, right? I'm just kind of writing it down just to sketch. I'm kind of sketching my graph here. I'm not making it perfect, but it will give me a good comparison so I can start to think about what my statement might be about absorbency. So I wrote down, as you can see, on this bottom, it's called an axis, this bottom line. I put copy paper, construction paper, and paper towel. Now think for a minute. Can you think about what I might be putting up here? If you thought numbers of centimeters, you're right. So I'm going to put 0 down at the bottom, just like we've been practicing with measurement. Then I'm going to actually use the lines of my notebook to put 1 centimeter, 2 centimeters, 3 centimeters. Okay, there it goes. I'm going to go a little more, 4 centimeters, 5 centimeters, and I'm going to pause there. What number of centimeters do you think I have to go up to? If you said 8, you are correct. I want to make sure that I have enough to show all of my measurements, all of my data that I found out. Okay, so I went up to 8 centimeters. So again, this is just a little sketch graph, okay, not fancy, it's not perfect, my line is not perfect, but I'm kind of sketching out to see if I can decide which one is the most, which one is in the middle, and which one is the least. So let's try that out. So I'm going to take a look at my first piece of data, my paper towel, right? It's 8 centimeters. So let's see, here's my paper towel. I'm going to mark up on this top line 8 centimeters. And I'm going to, like I said, it's just a little sketch. Not perfect. So I'm just going to kind of sketch a little bit of a rectangle here. So it goes all the way to the top. Okay, and I'm going to just kind of shade in a little bit because it's with pen. So it's going to take a long time to shade that in. So it's just a little sketchy one. And then here I'm going to do construction paper, which is 3 centimeters. So I'm going to find 3 centimeters, mark it over on my line. Again, even though we're not using graph paper, it's really easy to use those lines to help us out. And then same thing, just kind of sketch it in. Okay, and last but not least, our little copy paper here only got up to 2 centimeters. So I'm going to make a little rectangle to show that too. And as you can see, I made a sketchy little bar graph here. Okay, so that's called a bar graph. And you can see because it's just has some rectangles. So I'm going to label it bar graph. Okay, so it looks just like that. So nothing fancy, very simple. And what this tells me is that the copy paper absorbed the least amount of water. The construction paper absorbed almost the middle amount of water, not quite, right? And then the paper towel, as most of you maybe have suspected, the paper towel absorbed the most. And if you think about what we use those types of paper for, it makes perfect sense. So the last step that I'm going to take is I'm going to go to the bottom lines here, and I'm going to think about my hypothesis, which of course was my paper towel probably would absorb the most because that's the purpose that we use it for, is to clean up spills and things like that. And I'm going to write a nice final sentence to kind of wrap up my science thinking and my little experiment that I did here. So join with me. I'm going to say, the paper towel absorbed the most water, comma, while the copy paper absorbed the least. Period at the end. Okay, so there's my little statement. So basically, I went all the way from doing my experiment to taking my raw data or information that I wrote down right on the spot while I was doing the experiment, to going into my science notebook, right? Putting down a date, naming my experiment, giving it a title, writing down what I found in a nice, neat way, and then even making a little sketchy bar graph right here. And then again, my last step was to write a statement that echoes my hypothesis or kind of answers my hypothesis and what I thought might happen. So as we work on science throughout the year, we're going to think about all the things that we can observe, the things we can make a hypothesis about, we can predict what might happen, right? Kind of like we do with our reading predictions, same process. And then we can also think about how we can test things out, how we can do a fair test. Remember, we want to only change one variable or one piece of the things that we're working on at a time. Okay, I hope you enjoyed this, and I hope you look forward to learning some more science this year.